Hello everyone, my name is Bart Mieszkowski and I am a network engineer working at the Amsterdam Internet Exchange. Today's presentation was done with Max Strzelewko, but unfortunately he couldn't be with us here today. So, all right, the outline. And jumping to the next, sorry. All right, a couple of facts about Amsterdam Internet Exchange. We are a non-profit, neutral and independent exchange based in Amsterdam, spread around 14 data centers with over 850 ASNs, with a traffic of above 6.6 terabits. This year we are 25 years old, so we had a small celebration, working with 56 people. Presenting our platform, it's a MPLS VPLS based peering platform with two LSPs between each pair of access switches over 2P routers. We have 10G, 100G access switch resilience. Yeah. This button. Sorry. Internationally, we are having 6 separate ISPs with over 900 parties connected, present in over 500 co-locations in 350 cities. So, coming back to the subject, I would like to talk about the AMS IX Management Network. And in short, our management network is internal AMS IX network which interconnects our infrastructure, including production switches, DWDMs, photonic cross-connect devices, etc. It's being used for managing of our production platform switches and also for collecting customer statistics as well as S-flow data. So it should be extremely reliable, since our monitoring system relies solidly on it. Also, when you are visiting our websites, you are going through the management network. So, what kind of issues did we see with our old management network? And a couple of plain facts about it. So in Amsterdam, we did have 22 switches, which were located in 40 data centers, plus one in our main office. On our small remote locations, we had 10 switches in total. And historically, our management network grew over the years, where we were adding side by side, and that's why we had a mix of different plain layer 2 devices from Brocade and still old Foundry switches. We used also the ring topology in our setup, and a couple of disadvantages that we had with it. A couple of times we experienced loop in our management network because the devices did not support any loop prevention mechanism. We had also partially isolated parts of our network due to a double capped in fibers. We have seen some MRP issues where some of the ports didn't recover after flapping. We did have also bandwidth bottlenecks. Some of the devices were end of life and end of support. And another important factor is that, as you could see on our previous slide, we had 3 MRP rings where every fiber between the switches was a separate dark fiber that we were paying for every month. As you can see here, we were using 30 DAC fibers for our production network, and besides this, 17 additional for our management network. So what we thought is to reuse the existing production dark fibers with DWDM muxes, and in this way we were able to build a fully redundant spine leaf topology for our new management network. So as I said and mentioned the facts about our network in the past and the disadvantages that we had, we needed to upgrade. We wanted to make our environment more homogeneous, to have the same hardware and software. And it got hard during the time to manage different devices on the network, so our aim was to make it more unified. The new devices would also bring more capacity for our internal cloud and more redundancy to avoid multiple switches oscillations we encountered before. So the question is where to go, which technology, brand, software, hardware to use. And as you might know, 10 years ago we didn't have so many options, but as you can see nowadays, it's kind of a puzzle to solve for choosing most suitable model for our network. We made some research and a couple of proof of concepts of the modern technologies and different vendors. As always, AMS tried to be at the networking edge, and we decided to go with a future-proof option and choose bare metal switches with one of the third-party software vendors. What is bare metal whiteboard concept? It's basically decoupling software from hardware on the devices, so buying switch without operating system and installing later anything that you can find on the market. There are a couple of software companies like Pluribus, Cumulus, Big Switch, IP Infusion and so on. You can buy and install the software from them and install it like on a server. Or you can also go with OpenSwitch, which is a free project. So introducing our choice. After looking into the technology and making proof of concepts, of course, we went for the Pluribus network solution with the S4048 only enabled switches. It gave us some useful features like SEMP, loop prevention that we were looking for, easy REST API, VXLAN, and their proprietary fabric design. So talking about fabric concept, let's look first at the classic switch plane approach. So here we can see a classic design of the switch that we are all used to. On the bottom we have data plane and then control plane, and on the top single management plane per switch. With the new solution, the data and control plane for the underlay of each switch stays the same, like in a classic design, but the management plane is in common for every switch in the fabric. All the switches in the fabric federate together in a peer-to-peer fashion through a distributed SDN implementation. Practically saying every switch is still independent, but you can log in and see, configure any switch from any switch you are connected to. You can add an ACL and it will be populated to all the switches. It gives you a really ease of use. So, a little bit background on how does it work. Each box establishes basically a TCP management connection to every other box. Every box has a micro SDN controller and the state database to track the state of all other switches in the fabric. This works well over geographically distributed sites because there is no central controller. So effectively it looks like one programmable entity, and the system automatically builds VXLAN mesh. The network operating system, in addition to running standard protocols in the underlay, establishes also a VXLAN overlay with VTEPs terminated in hardware on the switch. The VXLAN tunnels are auto-created and establish a full mesh of tunnels. So this is how it try to represent it, how it looks from inside of the device. And in earlier versions of bare metal switches, there are indeed two different boards. One is switch with an ASCII, and another on the top is Intel Atom or ARM board. Some of them have even a VGA connector on the switch. In a Pluribus solution, there is a Ubuntu Linux installed, which controls the box itself, and Broadcom ASCII via an internal API. There is also an LXC container with Quagga installed on it for BGP OSPF. So this is how I try to a little bit visualize how the L2 and L3 communication works. One important feature that we were looking for was the ability to connect critical infrastructure as our NAS or production web servers to two switches simultaneously to avoid any downtime in case of maintenance or a failure of one of the devices. This requires creation of a cluster between switches where we want to connect to MCLAC, the unaware devices, and on the top you can also see spine cluster to connect to non-VXLAN switch, and on the bottom leaf connecting it to the server. So in the end we have built a spine and leaf topology network for our management use. Geographically distributed fabric built over a standard OSPF underlay. It's loop-free. There is no controller, no split brain scenario. MCLAC for critical services, improved visibility. And our experience is a simple management of our management network so far. Thank you. Any questions? Thank you very much.
Yeah, you have a question?
Did you just use the underlying DWDM transport to establish a point-to-point connectivity, logically, but your DWDM DWDM transport is still physically a ring. What did you do?
We reused the colors on our DWDM muxes.
Okay.
Yeah.
To come up with a spine leaf architecture.
Yes.
Okay. Thank you.
Any other questions?
I guess related to that, so double cut could still cause you a problem? You had something about that.
Basically, yes. We do have a spine and leaf, and it goes to two separate collocations.
Okay.
Yeah. All right. Thank you very much.